So today in the second session of the module 1 we shall study what do we mean by diode, how it is being formed. So first, what do you mean by p-n junction diode? Here you can see p and n junction, p type of material and n type of material combine to form a p-n junction, so that is called as diode. A p-n junction is formed by doping one side with p-type impurity and the other with n-type material. So what do you mean by diode? Diode are two-terminal component made from a single piece of semiconductor material which has a positive p side at one end and negative n side on other hand, and which has a resistivity value somewhere between the conductor and an insulator. Let me write how it actually works. This is how your diode looks like. Okay, this will be positive terminal and this will be negative terminal. The positive is called as anode, this is called as cathode. Okay, anode means p type of material, cathode means n type of material. So here you can see the current flow here will be IF. So this is a diagram P and N. This can be written in the form of this symbolic representation. So let us discuss in D type. You can see P type and N type material. Here trivalent impurity is added to a P type material. For N type, pentavalent impurity. So majority charge carrier will be hole in the P type. In the N type it will be an electron. So in the unbiased condition there are three conditions: unbiased, forward and reverse. Unbiased means we are not giving any kind of supply to it, we are just diffusing P and N type of material. Okay, in the P type, as the holes are the majority charge carrier, in the N type electrons are the majority charge carrier. When we add these two, what happens? The electron diffuses from the N region to a P region. Okay, you can see here electrons diffuses, here holes diffuses. So because of this there is a region called as diffusion region which is formed. You can observe here diffusion region which is formed here. So this is depletion region, and it is formed due to the creation of ions between the junction. So next is a barrier. Potential barrier is created due to the depletion region, due to which the ion cannot move from one region to another. So you can see there is a potential barrier which is formed. Okay, first thing you need to remember what happens when P and N type materials are added together. As P type has a holes majority charge carrier and N types as an electron, so when they are combined they diffuses. Okay, there is a depletion region that is created and that creates a potential barrier. Okay, so next you can see the electron flowing. You can see here depletion region is formed. When the diode is unbiased, the flow of minority carriers and the majority carriers across the junction will cancel each other. So overall the current under this unbiased region will be 0. So this was the question which was asked in the last semester, I mean the last model paper. So what happens? Try explain the unbiased p-n junction region. So what you need to know is due to the flow of minority carriers and the majority charge carrier, the current flow in this region will be 0. Okay, so electron flow due to the electric field, minority carriers, and electron flow due to the diffusion, majority charge carrier, they cancel each other. what happens when it is forward bias? First thing you need to know, what is forward bias of a PN junction, PN diode. So here you have a P and N. The diode has been connected to a supply here. Okay, supply. When the positive of the battery is connected to a P type and negative terminal to the N side, diode is said to be a forward biased. Okay, diode is said to be a forward biased. When the PN junction is forward biased, the applied positive potential repels the holes in the P region and applied negative potential in the N type repels the, what happens in the N type, which are the majority charge carrier, electrons. It repels the electrons in the N region. So the charge move towards the junction and hence the potential barrier, this width, will widen or reduce. So as well as the width of the depletion region is reduced. I repeat it again. So this was your P and N. Okay, we are connecting some voltage. So voltage is positive is given to a P type and negative is given to a N type. What happens is, in this P type, the majority charge carriers are holes. In the N type, the majority charge carriers are electrons. So when we give this positive to positive, so it will repel. Here, when the negative is given to a electrons, I mean N type, majority charge carriers are electrons, so again electrons will repel. So what happens to this depletion region or the potential barrier is, the width of this is being reduced. Okay, so that is overall working of your forward bias of a PN diode. So coming into a reverse bias condition of the PN diode, here what happens, it is a reverse process of the forward bias. So here what we are doing is, we are connecting, you can see here, negative to the P type and positive to the N side. So what happens here is, when the positive terminal of the battery is connected to N side and negative terminal to the P side, the junction is said to be reverse bias. When the PN junction is reverse biased, the electron in the N region and holes in the P region are attracted from the junction. The number of negative ions in the P region and positive ion in the N region increases. Hence, the depletion region becomes wider and the potential barrier is increased. Since the depletion region does not contain a majority charge carrier, it acts like a insulator. So here you can see the VI characteristics of the diode. So during the positive forward bias, what it happens, and during the reverse bias, what it happens. So in the forward bias, you can see they have taken two examples, silicon and germanium. So reverse bias, they have taken an example. So this is how it actually works. Diode works in the forward and the reverse bias. It is a plot versus voltage versus current. So you can see during the forward bias, initially there will be it will start increasing when you go on increasing. Okay, so in the reverse bias, usually there will be no current at all. Okay, once it reaches the breakdown region, it starts conducting. So once again, the PN junction is formed by N-type material fused together with the P-type material, creating a semiconductor. This is a symbolic representation, anode and cathode. So in the forward bias, what it happens, the voltage positive is connected to a P side and negative is connected to a N side. So what it happens, it decreases the width of the depletion region. In the reverse bias, the voltage potential is connected to a N side, I mean anode N side, and you can see here reverse bias anode to N side and positive to cathode. So what it happens, the depletion width of the it increases. Summary of it. So forward characteristics, the same thing. Forward bias characteristics, you can see how the movement of electrons and holes are taking place, and this is a narrow depletion region. So this is a PN junction. The reverse bias, the P side is connected to a negative and N side is connected to a positive. So width, main important thing is width of the depletion region is being increased. So this is a VI characteristics. You can see here germanium and silicon. Germanium conducting point is 0.3. For the silicon it is 0.7. What do you mean by resistance level? As the operating point of a diode moves from one region to another, the resistance of the diode will also change due to the non-linear shape of the characteristics curve. So here you have DC or static resistance. The application of DC voltage to a circuit containing a semiconductor diode will result in an operating point on the characteristics curve that will not change with time. The resistance of the diode at the operating point can be found simply by finding the corresponding VD and ID. So RD is given by VD divided by ID. This is a formula to find out the resistance. So what do you mean by AC or dynamic resistance? If a sinusoidal input is applied, the varying input will move the instantaneous operating point up and down a region of characteristics and thus defines a specific change in current and voltage. So RD is given by del VD by del ID. So this completes your what do you mean by what we studied in this section is what do you mean by PN diode, forward bias, PN junction diode, what happens, reverse bias, so VI characteristics of forward and reverse, resistance level. Okay, we shall discuss about few more topics in the next session. Thank you.